Welcome back to The Deep Dive. This is where we take a stack of sources, case studies, field notes, research, and give you that fast track to being the most informed person in the room. Today, we're looking at something that sounds, well, almost too simple. Industrial packaging.
Right.
You think about world-class precision engineering, I mean massive components for mobile lifting equipment, and you assume all the risk, all the complexity is in the mechanics.
In the metallurgy, the engineering itself.
Exactly. But our sources today, they reveal this really profound truth. Often, the biggest vulnerability is in the simplest thing, the box it comes in.
The packaging that's supposed to protect it.
We're diving into a very detailed case study. It's from a family-run manufacturer in Germany, and they specialize in these enormous, highly sensitive crane components.
Masters of production. I mean, top of their field.
Top of their field, but the source material captures this crucial admission from their logistics manager, Johanna. She said, and I'm quoting here, "Even the best-made products are only as safe as the packaging that protects them."
And that really sets the stage for our mission for you, the listener. This deep dive is all about how solving one seemingly small technical problem uncovered and then eliminated three major blind spots.
Inefficiencies that they had just accepted.
Totally. They just saw it as part of the job. So we're really exploring the hidden value of, getting on site, that human insight in logistics.
So by the end of this, you'll understand why the true cost of bad packaging is never just the wood it's made from.
Oh, it's so much more. It's wasted time, it's huge damage risk, and it's long-term cost inflation that just creeps up on you. The blueprint for efficiency, in this case, it wasn't in a CAD drawing. It was on the factory floor.
Okay, so let's start at the beginning. The initial contact, it was incredibly tactical. The manufacturer needed foldable wooden boxes, plywood specifically, but they needed them longer than the standard size.
And this was for one-way shipping of really high-value goods.
Right. So they needed something durable, stable for that one critical trip, but without the cost of having to return the container.
And the sizes were, they were intimidating.
Yeah, the dimensions signal the scale of what they're making. They needed boxes from 2,400 millimeters long all the way up to a massive 4,200 millimeters.
4.2 meters.
4.2 meters. And this is where the story really pivots. A typical supplier would just quote the job, right? Fulfill the order.
Absolutely. They did the first run, but then the manufacturer came back with a second, very specific request for a change.
To the pallet bottom.
To the pallet bottom. And that second request, that specific modification, it was like a flashing red light. It told the packaging partner that something deeper was wrong with the process.
So just iterating on a drawing wasn't going to cut it.
No. They needed context. So they insisted on a full factory visit, a process walkthrough.
And that right there, that's the difference between just selling a product and actually optimizing a process.
Exactly.
Our sources, they paint this picture of them standing right there on the factory floor. You've got these long steel components everywhere, oversized crates stacked up. And Johanna, the logistics manager, she walked them through every single step.
And not just looking at the finished box. They watched how it was packed.
How the forklifts lifted it.
How it was stored, how it was loaded onto the truck. This observation part was non-negotiable because it's where you find the problems that, as the source material says, would never appear in an email.
It's fascinating, isn't it? When you do a really difficult task every single day, you develop workarounds.
They become subconscious. Organizational blind spots. You stop seeing the inefficiency itself and you just see the workaround as, well, that's just how the job is done.
Okay, let's unpack this then. The three big problems they found during that walkthrough. And these weren't just about the box, were they?
No, not at all. These are deeply embedded operational flaws that once they were solved, just completely changed the manufacturer's entire shipping game.
Let's start with challenge one, the bending pallet. A huge safety and component integrity issue.
And it was tied directly to the warehouse layout. The facility's architecture, tight aisles, specific racking, it meant the forklifts couldn't get at the long goods from the front or the back.
So they had to lift from the middle.
They had to lift from the center point of the pallet. And that center lift was causing havoc.
Because pallets aren't designed for that.
Not at all. They're designed to be lifted where they're strongest, usually at the ends. When you lift a heavy load from the center, you get enormous stress, this shear force, and it causes the pallet to bow downwards.
And even a few centimeters of bending, that sounds like nothing. But with these multi-$1,000 components, what was the real risk?
The risk was immediate damage. That bowing, even slight, created these internal pressure points. The expensive crane parts were literally scraping against the inside of the box.
So every time a crate moved across the warehouse, they were risking damage.
Every single time. And they had lived with that stress for years. Just accepting that risk is unavoidable.
Okay, so if the problem was bending, why didn't the partner just say, use thicker wood? Or add more supports all along the bottom? Wouldn't that stiffen it up?
That's a great question, because that's the obvious reactive fix. But just adding material adds weight.
Which adds cost.
Both material cost and, more importantly, future shipping costs. The genius here was in optimizing the structure without making the whole thing heavier.
So it was a more surgical approach.
It was a two-part, very surgical solution. First, they engineered a specific side opening in the pallet wall.
So like a slot.
Exactly, a slot. A strategically placed aperture that let the forklift forks slide in right at the perfect central balance point without wrecking the pallet's structure. That solved the access problem.
And the second part?
The second part was the load transfer solution. They installed heavy-duty wooden supports inside the box, aligned perfectly with where the forklift was applying pressure.
So the load is transferred through those supports.
Precisely. So when the central lift happened, the crate stayed perfectly straight. No bowing, no bending.
The impact must have been immediate.
It was. The source material quotes Johanna, the logistics supervisor. She just sounds so relieved. She says, "This is the first time the pallet stays perfectly straight. This alone saves us the stress we've had for years."
That's incredible. Just eliminating that daily stress through smart design.
It's a huge win.
Okay, so let's pivot from preventing physical damage to eliminating wasted time. This brings us to challenge 2.
Right. Optimizing the strapping flexibility. This was a massive drag on their packing speed.
Once the structure was sound, the partner looked at the human side of things.
And what they saw was that these crane components had, wildly different shapes, different widths, complex geometries. So the strapping needs were never the same.
Sometimes 2 straps, sometimes 4.
And the best tie-down point was always changing. So the workers, with the old pallet design, had to stop, measure, improvise. Basically hunt for the right spot to secure the load every single time.
That sounds like a classic example of operational inertia.
Absolutely. It's the death by 1,000 cuts for efficiency, a few extra minutes on 30 boxes a week. That adds up to weeks of lost productivity over a year.
And the time drain becomes invisible.
It does, because it's just seen as part of the job's complexity.
So what was the design change here? It sounds like it was brilliantly simple.
It was. They completely redesigned the upper deck of the pallet. All the wooden planks on that deck were spaced about 50 millimeters apart.
50 millimeters, a 5-centimeter gap. That almost sounds too small to be revolutionary.
But that little gap created these uniform slots that let workers pass straps through the deck at any location they wanted.
I see. So instead of having fixed tie-down points,
the entire deck became a continuous grid of possibilities.
That is phenomenal. It's like designing flexibility directly into a rigid object.
It is. The result was that workers could just secure any shape quickly without having to think about it or improvise. The packing team reported that this one change reduced their loading time by many minutes per box.
Which in an industrial environment is a massive quantifiable win. And that really sets the stage for the final challenge, which takes the savings outside the factory walls and onto the truck.
Right. Right-sizing the shipment. This was all about wasted volume.
So the original design was a one-size-fits-all box.
Correct. Yeah. It was designed to handle the tallest possible component they made. But the reality was maybe 60% of their orders were for smaller, more compact crane parts that didn't need all that height.
So every time they shipped a smaller item, they were still using the big box they were paying to transport empty space.
In the logistics world, that's what we call underutilizing your cube capacity.
Right.
Or, dead freight costs.
Right.
Freight carriers charge based on either actual weight or dimensional weight, the volume your cargo takes up. So using an oversized box guaranteed they were paying too much for shipping. They were paying to ship air.
So the solution had to bring that same flexibility to the vertical dimension. What did the partner come up with?
They delivered 2 compatible wall heights, a standard height for the big, complex components and a lower height for the more compact cranes.
So simple, but it changes everything for planning.
It changes logistics planning dramatically. The planner can now pick the optimal size for every single shipment. They can load the truck more densely, maybe stack more low-profile boxes. They can use every cubic centimeter they're paying for.
They went from static expensive shipping to dynamic, efficient transport.
Exactly.
This is just a tremendous story of value. What started as a simple request for a long box
You need some long boxes.
turned into this full optimization project. It delivered safer handling, less damage, faster packing, and way better transport utilization.
And if we just circle back to the core lesson, it's so clear. Industrial packaging is not a commodity. It's not just a purchase. It is a critical link between your high-stakes production and your customer.
And the complexity wasn't in the crane component itself. It was in the world it had to travel through.
And the key differentiator, the thing that created all this value, was the decision to get out of the office and onto the factory floor. The real insights didn't come from a technical drawing.
They came from watching a forklift operator struggle.
Seeing a worker hesitate with his strap. Observing Johanna's daily frustrations. They just challenged the accepted way of doing things.
And the final word from the customer really says it all. Their engineer, looking back at the whole thing, said, "We were looking for boxes. What we received was a set of solutions that helped us rethink how we ship."
That's the definition of a true technical partner.
It is.
And this all raises, I think, an important final question for you, the listener, to take away. In your own life, professional or personal, where have you internalized an inefficiency, a bottleneck?
Where have you developed workarounds that have just become the way things are done?
Exactly. Just because you haven't taken the time to really walk through the process and question the basic design assumptions, what system are you running right now that just needs a 50-millimeter gap added to be completely revolutionized?
That's the real challenge, isn't it? Sometimes the solution is startlingly simple, but the insight only comes from getting up close and being willing to question why things are the way they are.
You have to see it to solve it.
Go look closer at your own processors. We'll see you next time on The Deep Dive.